Imagine a silent intruder streaking through the void, a relic from a distant star, hurtling past our sun at unimaginable speeds. The latest images of 3I/ATLAS, captured in late 2025, don't resolve the enigma. They deepen it profoundly. This interstellar comet, the third confirmed visitor from beyond our solar system, challenges everything we thought we knew about cosmic wanderers. If it's truly just a comet, it's the most extraordinary one we've ever encountered. But the fresh data from Hubble's sharp gaze to X-ray visions from space observatories hints at behaviors that defy easy explanation, leaving scientists grappling with questions that echo across the galaxy. It all began on July 1st, 2025, when the NASA-funded Atlas telescope in Chile spotted a faint, hyper-fast object slicing through the outer solar system. Within days, pre-discovery images pushed the timeline back to mid-June, revealing an inbound trajectory unlike any bound to our sun. Astronomers quickly calculated its hyperbolic path, an eccentricity far exceeding one, confirming it originated from interstellar space. Named 3I/ATLAS for its status as the third interstellar object, it joined the elite company of Oumuamua in 2017 and Borisov in 2019. Yet from the start, this visitor stood apart, blazing in at over 137,000 miles per hour, unbound and unstoppable. Early observations painted a classic cometary portrait, a bright coma enveloping a hidden nucleus, with subtle hints of a tail emerging as solar heat awakened its ices. Hubble's first snapshots in July 2025 showed a teardrop-shaped dust cocoon, while ground-based telescopes detected a reddish hue in the coma, reminiscent of ancient, dust-rich bodies. NASA and ESA swiftly mobilized an armada of spacecraft: Hubble, James Webb, Parker Solar Probe, MAVEN at Mars, even distant missions like Psyche and Europa Clipper to track this fleeting guest. But as 3I/ATLAS swung around the sun on October 29th, 2025, at just 1.4 astronomical units, the new images began to unravel the narrative. Consider the view from Parker Solar Probe in late October and November. Rolling its axis to capture the comet against the solar glare, it revealed a dynamic outflow, dust and gas streaming in ways that hinted at uneven activity. Then came the X-ray revelations. Japan's XRISM and ESA's XMM, Newton observing in November and December, detected the first ever X-ray glow from an interstellar comet. Soft X-rays fanned out hundreds of thousands of kilometers, produced as solar wind-charged neutral gases like water vapor, carbon dioxide, and monoxide, substances Webb had already confirmed in infrared spectra. This was groundbreaking. Previous interstellar visitors showed no such emission. Yet the intensity and extent raised eyebrows. Why so vigorous for an object that had endured billions of years in the frigid dark? Deeper intrigue emerged from Hubble's revisit in late November and December. Post-perihelion images unveiled wobbling jets in the coma, twisting structures suggesting rotation or multiple active vents on the nucleus. An unusual antitail pointed sunward, a collimated stream of larger particles lagging behind due to the comet's non-gravitational acceleration. Processed frames showed dual jets, perhaps from opposite sides of a spinning core, their relative brightness shifting night to night. Ground telescopes like Gemini North captured a faint greenish tint in November, echoing solar system comets driven by diatomic carbon, but spectral data indicated surprisingly low levels of those molecules. How, then, does it glow so vividly? Composition added layers of mystery. Webb and ground spectra revealed abundant CO2 and CO outgassing, even from afar, with water vapor dominating closer in. Cyanide and atomic nickel vapor appeared, common in comets, but iron, typically paired with nickel in equal ratios, was conspicuously scarce in early detections, evoking industrial alloys unseen in nature. Later observations found some iron, yet the extreme nickel dominance persisted as an outlier. MAVEN's ultraviolet images from September showed a vast hydrogen envelope, while Mars orbiters in October glimpsed the coma from mere millions of miles away. Perseverance rover on the surface even caught a faint smudge against Martian stars. Size estimates refined through these multi-wavelength views place the nucleus between 1,400 feet and 3.5 miles across, shrouded in a coma that swelled to tens of thousands of kilometers. No outbursts or fragmentation marred its journey, unlike Borisov, steady, almost deliberate in its activity. Europa Clipper's ultraviolet spectrograph in November pierced the tails from a unique angle, detecting subtle ion interactions. JUICE en route to Jupiter snapped navigation camera teasers in November, hinting at dust tails stretching invisibly far. These cumulative portraits, from optical to X-ray, paint 3I/ATLAS as profoundly ancient, potentially 7 to 14 billion years old, forged in the thick disk of our galaxy before the sun ignited. Its tilted galactic orbit speaks of a violent past, perhaps ejected from a long-dead system. Yet anomalies abound. The persistent anti-tail, wobbling jets, mismatched chemistry, and that puzzling green glow without abundant C2. Harvard astrophysicist Avi Loeb has highlighted these, updating his scale of potential artificial origins, though mainstream consensus holds firm. It's a natural comet, albeit a weirdo shaped by eons in interstellar radiation. Speculation swirled online. A mothership seeding probes near Jupiter, an artifact ignoring Earth on its closest pass December 19th at 170 million miles? Breakthrough, listen, scan for technosignatures during that approach. No signals detected. Agencies like NASA and ESA emphasize its natural origins, yet admit the data sharpens our tools for planetary defense, integrating spacecraft tracks from Mars orbiters into global databases for the first time. As 3I/ATLAS fades outbound, dimming into the cosmic night, it leaves us humbled. This visitor, observed from every vantage in our system, reminds us how little we know of the galaxy's drifters. Each image, each spectrum, peels back a layer of the universe's vast history, carried on an icy messenger that brushed our doorstep and vanished forever. What secrets did it truly carry from the stars? The question lingers, urging us to watch the skies more vigilantly, to wonder deeper about our place in the cosmos. If another arrives, and statistics suggest they will, what new revelations await?